Okay, can you see my screen? Is it visible? Can you see my screen?
Yes.
Okay,
We
thank you.
can
So
see.
let's go start. Okay, so basically today's session I discuss about this type of topic. So basically how we can easily calculating any indices from satellite images, Landsat or Sentinel, and how to filtering and displaying the satellite images, mainly Sentinel-2, monitoring the NWI or NDVI. So this type of indices how we can easily monitor. And we'll also discuss about the extract the water body using remote thresholding technique. We also discuss about that, and how to make the time series chart for NDVI, NDWI, or SAVI or any other indices. How we can easily create the time series chart using Landsat or Sentinel imagery. We'll also discuss about that, and how to export shapefile. I think this topic I already discussed. How to add gradient legend and title on Google Earth. We'll discuss about that, and also discuss about the flood mapping, how we can easily extract the flood mapping using the Sentinel-1 SAR data. We'll also discuss, and discuss about the monthly time series chart of NDVI, NWI, or any other indices, how we can easily create. So let's go. I will try to explain all of those step by step. Then I hope we can easily get that all of things properly. Okay, so okay, so let's go. First of all, I try to discuss about one project. Suppose how we can easily monitor the water increase in the during the rainy season. Okay, suppose these things, how to detect water increase during rainy season. Okay, so these things I try to do, how to detect the water increasing and how much water increasing. So this type of things I try to show you that step by step. Then I hope you can easily get the idea, and it complete all topics. Okay, I try to understand. So let's go. So first of all, in this case, you simply import your study area. Suppose I want to import my study area. Um, okay, just import my study area. So this is my shape file here. I already imported. So I import it and then I give a name, suppose as a ROI, and then just display the study area. Just add a layer of ROI and also focus on a given shape file. Just ROI and zoom level suppose 10. Okay, just run. So now this is my study area. So for this study area, I want to monitor the rainy season and also summer season. So two time period, I want to detect the water body, and I want to compare the result of how much water body increase in the rainy season. Okay, I also try to compare. Okay, kindly mute. Yeah. So first of all, I need to imagery. Okay, so you need to import your imagery. Okay, in this case I need the imagery. Suppose I want to work for Sentinel. Okay, Sentinel imagery I want to use, and this imagery I need for two season. Okay, I need for suppose summer season, and also I need for rainy season. So two time period I need the imagery for my study area, summer season and rainy season satellite imagery. So further I want to monitor the water body and also compute it how much water body increase in the rainy season. Okay, then we can easily detect this type of place. It's a water body, but in the summer season there is no water body. Okay, then we can easily detect the water logging condition. So let's go. So first of all, I need to import the satellite imagery. So just click on here and go to the browse data catalog. And I want to work for Sentinel. And I want to work for Sentinel 2 multispectral instrument, this imagery, and I want to work for this surface reflectance satellite imagery. Okay, so this is the satellite imagery. So this is the Sentinel 2. It's a 10-meter resolution. You can see band 2, band 3, band 4. Okay, this is the 10-meter resolution, and band 5 is 20 meter, band 6 20 meter. Okay, so all of bands are the same scale value. You can see 0.001. Okay, so this type of scale value, further we also need to multiply to get the more accurate pixel value. Okay, so let's go try to work with this imagery. First of all, you need to copy this snippet ID, just copy, and then paste on your code editor. Just paste here. Okay, then give a variable name. You can put any name as a variable. Before the variable name, just use here the var keyword, and you can put any name as a variable. So I put here the variable name, suppose S2. Okay, you can put any name. So now this is my image collection. This image collection, I just store it in this variable S2. So now we are just applying the filtering process. So how we can filter, we already know about that. For filtering process, put here the filter bounds function intersecting with your study area. In this time my study area is the Dhaka city boundary. It is stored in the ROI. So just put here ROI. Okay, then we filter a specific time period. A specific time period, mainly I just take the imagery, suppose in year of 2024. Okay, in year of 2024. In 24, I want to need the image for dry season and summer season. So in 2024, whole year I take, and further I filter rainy season and summer season. So I take the full year, suppose 1 year. So filter date, I put suppose year of 2024, 1st January, from year of 2024, December 31. So I take the whole year, and further I also make the filter again. Okay, for summer season and rainy season, I just separate. So first time I take it all of full year. Okay, for in year of 2024. So now I also filtering the metadata, mainly image properties. So you can easily get the image properties. You can see I choose for cloud pixel percentage, this property name, paste here, and then set here less than, I set the value suppose less than 1. Okay, so now we find out this type of let me check how much image is available for the 1 year. So just call the S2 and use the size function and run the code. So now it's computing how many images are available in year of 2024 for the whole year. Okay, so we find out the 25 images is available in the whole year between this time period. After that, if you check, this imagery have some value, scale value. So this scale value I need to multiply. Okay, this scale value I need to multiply all of images. Okay, all of images I need to multiply. So if you want, you can simply put here, suppose if I just put here multiply function, suppose just put here dot multiply and put this value 0.0001 and run the code. We find out this type of result. You can see it show this type of problem. So we find out this type of problem. It show that image collection filter bounds filter dot or is not a function. Okay, so it's some problem. Okay, so I want to multiply this value. I want to multiply this value all images. All images, mainly how much images you can check. How much images? They are total 25 images. I want to multiply this value. Okay, all of images at the same time. But when I multiply, then it's create a problem. This problem is that it's not a function. You can see if I run the code again, just uncomment and run the code, you can see it show a problem. So now what's the solution? How I can multiply this value 0.001 all of images at the same time. Suppose at the same time I want to multiply all of images, this 25 images I have in my collection, and I want to multiply this value 0.001 okay, with all images, mainly all 25 images I want to multiply. So now how I can do that? So for that we are just use the concept of function. Okay, we already know about the function, so we just create a function. This function help you to multiply with this value all of images at the same time. So let's go, I will show you that how I can create a function. So for creating the function, just take a variable name. Suppose I put the variable name is that s2 equal, you can put any name, there is no problem. I put the s2 and then I just create a function. Okay, I create a function and put the function element name, suppose img, and put the curly bracket. In this curly bracket I just put my argument. So this is the basic structure of the function. We already know about that, I already discussed in the previous first class. So these things is the basic structure of function. So now I just create a function, variable name is s2, and then put the function keyword and put the element name img and put my argument in the curly bracket. Between the curly bracket I just put my argument. So what is my argument? My argument is that I want to return this element multiply with a value 0.0001. Basically this is my scale value 0.001. Okay, so just I use one element. Okay, I just use one element and multiply with that. After that I need to apply all images. Okay, basically I take only for the one element, but I have also rest of other images. For rest of the other images I just use a function, this function called the copy properties. So this copy properties I copy from element and it's apply system time start to system time int. It means that I already have a system. This system I already defined the start time and already defined the end time. So now between this time all of images I consider and apply this multiplication 0.001. So now this is my function and this is my collection, total 25 image collection. So now we just need to connect, So how I can connect? So for connecting just use the map function. So for that just call this variable name s2, this variable I just call and paste here and then use a map function, use the parenthesis and also close this parenthesis. So now all of images is multiply with this function 0.001. Okay, so this is the process. So first time I just apply the multiply function in here. It's not work because this multiply function is only work for image data type. If you check the function, suppose just simply click on here and check the e.image, you can see e.image. If you check, you can easily find out a function, this function called multiply. You can check where is multiply. Yeah, you can see the multiply. Okay, so multiply function is only work for image, not image collection. But sometime you also need to multiply with image collection. Okay, suppose in this case I have total 25 image collection. Okay, so then how I can multiply? Then we are just create a function and then use the map function for connecting. Okay, so now this variable store all of images with multiply with this value 0.001. Okay, but when I multiply in here then it will be not work because multiply is a function of image data type. If it's a single image, suppose s2, if the s2 is a single image, then multiply is easily work, there is no problem. But now s2 is a collection of images, total 25 images, that's why multiply is not work. So then I just create a function I just create a function and multiply. I hope you can got the idea how it will work. Okay, so now this variable is stored all of those, and if you want this code, you can also write another way. Suppose this same code I want to write another way. So how I can do that? Very easy. Just copy from here, just copy and then paste. Just paste here, just paste here. So now I just use only one variable and I create a function and multiply. Okay, just use the one variable s2. So now all of those just store it in the s2 variable. Okay, if I run the code, there is no problem. It means that it successfully multiply this value 0.001 and total 25 images multiply with this value. There is no problem. So this is the another way to write the code. Just I use this single variable s2 and I create a function, create the function. So this is my function and this is my collection. Just use the map function for connecting. Or if you want, you can also take the another variable, look like that. Just take the another variable and write the function. Okay, so this is the two way we can follow. There is no problem. Or you can just take the only for the one variable, take the one variable, just take the s2 variable, and under this variable you can write the function. There is no problem. Okay, so I take the first one. So run the code. So now we find out the total 25 images, and all images are multiplied with the value 0.001. Okay, so it's help you to get that more better reflectance value for Sentinel-2. Okay, so now we find out this type of imagery, 25 imagery, and this 25 imagery we already multiply with our scale value 0.001. Okay, so after these things we need to create the dry and wet imagery. Okay, so just we take the imagery for dry season and also take the imagery for rainy season. So for that, just take a variable. Suppose I put the variable name, suppose dry image, and I just take it from this 25 images s2, because this s2 is stored at the 1 year. Okay, so from the 1 year I just take only for dry season. Okay, so I put for 2024 of January to 2024 May 31. Okay, so now I just check how many images in the dry season I find out. You can see, just use at the dry image and use at the size function. So now it's computing how many images are available in the dry season. 15 images we find out in the dry season, and rest of the other for rainy season. Okay, so now these 15 images I just create the composite. Okay, I create the composite. If you want, you can also work with the single date imagery. There is no problem. I want to create the composite. Suppose I want to create the mosaic composite. Mosaic. So what is the mosaic? So you can simply search on the docs tab and then check what is the mosaic function. So mosaic function, you can see it's work for the image collection. Okay, so I have total 15 image collection. So this image collection I want to apply the mosaic. So mosaic is it's work for the collection. Okay, if you check it, composite all the images in a collection. So I have total 15 images in my composite, all the images in a collection using marks, and it return. Okay, when I apply this function, what I return? When I apply this function, then it return image, just single image, just single mosaic image. Okay, it return only for the image. So let's go, we try to apply this function mosaic in our in here. Just copy and just mosaic I already write, and then when I apply the mosaic, then it will be just a single mosaic composite image, and any image we can simply clip. Okay, clip function is only work for the image. So if you check what is the clip, just simply search here clip. You can see clip is work for the image, ee.image, and when I put here the mosaic, then it work as a single image, and then clip is easily work. Okay, what is the clip? Clip, you can see clip an image to a geometry or feature. So in this case, my geometry or feature, it is the Dhaka city boundary. It is stated the ROI. So just I put here ROI. Just put here ROI. ROI. Okay. So we done it for dry season. So same as for we did for same for rainy season. Okay. Then we try to visualize this imagery. So just take a variable. So suppose that it's a rainy season. Just take a variable. Suppose wait image, and then call. Okay, just I copy the same line of code. Just copy and paste here. Simply change the time period. Okay. So for the rainy season, I put here 06 to October. Okay, just I put and mosaic. So now we create the dry image and wet image. Now I want to visualize this two time period imagery. So let's go try to visualize. So just use here map.add layer and call the dry image. Just copy and paste here and run the code. So now it added a layer of dry season imagery. So it looked like as a black color, but if you want, you can also add here the band combination, then it will look more better. So let's go try to add it. Suppose I want to put here red, then green and blue band, stressing suppose 98%, and apply. So now you find out this type of natural color imagery look like that. And now import and copy this parameter and paste after the object name. So this is the object. I put here these things and give a name. Suppose it's a dry image or dry season image. So now same for do for the rainy season imagery or wet season imagery. Just call the wet image and paste here and run the code again. So okay, you can see it show a problem. This problem is that in the dry season, in the rainy season, there is no image. Okay. Okay, so let me check how many images available for that. Just print. I think there is no image less than 1% in the rainy season, so that's why it's not loaded to the layer. So just use the size function and just run the code. So now let's check how many images available in the, you can see 0. Okay, so it means that in the rainy season there is no image less than 1% cloud cover. Okay, there is no image less than 1% cloud cover. There is no image. So now further how I can solve it? So just you can increase the training cloudy level. Okay, so if you check it, the cloud level I put here less than 1%. So just I put less than 5%. So now let's check what happened. Okay, it is still show the no imagery. Okay, let me check for 10%. We find out the two imagery, you can see. Okay, we find out the two imagery in the rainy season. Okay, so let's go try to use it. Okay, so for that just make the mosaic using this two images. We just make a mosaic. So just apply the mosaic and clip with our shape file which is ROI. So just run the code now. Okay, it's a problem because size function is only work for the collection, but when I apply the mosaic, then this variable it work as the image, not image collection. That's why it show this type of problem. So now run the code. Okay, so now it's work. Yeah. So we find out this type of imagery for the rainy season. So let me add the band combination for that. So put here red, then green, and blue, and custom stressing 98% I keep, and then apply it, and also import. Just copy and paste after the object name, and give the layer name. Suppose it's a rainy image or rainy season image. So now run the code. So now if you check, we find out two imagery for our study area in Dhaka city, summer season and rainy season. We find out. Okay, so you can see find out this type of imagery. So this is the imagery for rainy season, and this is the imagery for summer season. Okay, so now I get this type of imagery, and now from this image I want to monitor water pixel. Okay, suppose from this imagery where I have water, and also for the rainy season imagery where I have water, so I want to detect the water body from two imagery, and further I want to compare the water logging area. I want to detect the water logging area, and also calculate how much area have water in the rainy season. So now how I can detect the water body from two imagery. So in the remote sensing we are use different types of index. Okay, we are use different types of index. If you simply search on the Google, suppose water index or water index in remote, I simply search here. So you find out lot of paper, lot of equation, lot of things we can easily find out. So just let me open it. So you can see the types of water index and their application. So we are use different types of water index for the different types of application. Water index as a monitoring tool, if you check, so different types of index. So this one you can see NDWI. So it's called the normalized difference water index, and it's computed this formula, near minus short wave infrared 2 divided by near plus short wave infrared 2. So it's one kind of formula for NDWI, and this is the monitor application of the NDWI. So different types of application you can see. Also you can see this is the another formula, it's called the WRI, water ratio index. So this is the formula about the water ratio index. Okay, also you can see the another formula for MNDWI. So this is the another formula for water index. So this is the formula about that, green minus short wave infrared 2 divided by green plus short wave infrared 2. So we are using different types of formula to detect the water body. Also you can see the NDSI. So basically it's the Suno index, normalized difference Suno index, and it's computed this type of formula in the Suno area. So it's very helpful identifying Suno from the vegetation, soil, or in elements of lithology. So this type of formula we are just used to extract the water body from satellite imagery. Suppose I want to apply this formula, just a copy. I want to apply this formula in these two satellite imagery in the summer season and rainy season, and then I want to detect the water body. So let's go try to apply it. Okay, so for that, first of all, okay, this is the formula. This formula I want to compute using dry imagery and wet imagery. I want to compute these two imagery. So let's go try to apply it. So for that, there's a lot of way to compute this type of equation. There's a lot of way. So first method or first way, it's called that normalized difference function. Okay, so normalized difference, it's one kind of function. It's computed normalized difference between two similar band. So in this case, green band and short wave infrared 2 band. also green band and short wave infrared 2 band. If you check the function more more details, simply search here normalized difference. So this is the function you can see, and this function, normalized difference function, is only work for image data type, because you can see e.image, so it's the data type. So this function is not work in the image collection, okay, directly, but this function is only work for that image. So this function I want to apply in two satellite imagery, dry imagery and wet imagery. I want to apply this function. So if you read, you can see it compute the normalized difference between two bands. If the bands used are not specified, use the first two band, okay, and this normalized difference is computed first band minus second band divided by first band plus second band, okay, and noted that it returned the image band name is ND, okay, it's the default name. It returned the band name is ND, and what I return from here, this function return a image of NDWI or MNDWI, which you write. So this function I want to use and compute. Just I copy, and you can see in the argument is the band name, okay, argument is the band name. We are just put at the band name. So just I use it. Suppose I put a variable name. I put the variable name, suppose MNDWI dry. Okay. So just call the dry image. Okay. So this variable is stored at the dry season imagery. Just I copy and paste here, and then apply the normalized difference function. Normalized difference function, and then put the band name. So I need the green band and short wave infrared 2 band. Okay, what is the green band? You can see green band, its name is the B3, and short wave infrared 2 band, this name is the B12. Okay, just I put here B3 and B12 as a list. So B3 and B12. So now it create MNDWI. Okay, so if you print, suppose I print MNWI dry and check the information, just run it. It's an image, you can see it's the image. Okay, and it's create the one band, and this band name is the ND. Okay, it's the default name ND. Suppose I want to change this band name. So for that, you can apply the rename function, and put the band name, suppose MNDWI, and run the code. So now it's show the name MNDWI. You can see MNDWI. Okay, so let's go try to display this map. So for displaying this layer, just apply the map dot add layer function, and then call the MNDWI dry and paste here and run the code. So now it's add this type of map. You can see, find out. So now I want to add the color to display this map more better. So how I can add the color? It's very easy. We already know about that. Just click on the layer. You can see this layer is for MNDWI. Just click, and I want to add the, first of all, I just apply the tracing to get the more better visualization, and I add the plated. So I want to add the plated. I add there is no water. It show as a red color. Greater than value, it show as a, suppose, yellow color. Then greater than, it show suppose as a green color, and greater than, it show as a blue color, because high positive value indicating about the water pixel. Okay, negative value, negative pixel, it's indicating the non-water, it's not the water. Okay, so greater than 0 or high positive value, it's indicating about the water body. So I put this type of color. You can put any color combination, then apply. So now it's added a this type of map. You can see just I import the visualization parameter and just copy and paste after the object name, and then give a layer name. I put the name, suppose it's a dry MNDWI. You can put any name. So now you find out this type of map for in the dry season. So here you can see find out this type of map. So you find out this type of blue color, it's indicating about the water pixel. Okay, it's a water pixel, and this is the map for dry season. Okay, so if you check the pixel value, just click on the inspector tab and click on the blue color pixel. You can see it shows the positive pixel. So you find out the positive value. Okay, all green blue color pixel, this result show as a positive. We find out the positive. You can see we find out the positive 0.4, and high positive will indicating about the high density of water. So if you check suppose this type of place, it show the negative. Okay, we find out that negative value. Okay, negative value, it's indicating about that there is no water body. So this is the way. So now apply the same process for rainy season. Okay, just I copy the same line of code, just copy and then apply. So I put it's a MWI for wet or rainy season. I put here suppose rainy, and then call the rainy season image. So I already make the wet season image ready. So this is the rainy season image ready. Just paste here, and then it's the same. And then we try to add the layer. So map dot add layer of this. Just call the variable name and paste here. So now run the code. So now it's added the another layer of MNWI for rainy season. So let's go try to add the visualization first. So we find out this type of grayscale color. So then we just try to add the color. So let's go try to add the color. So just click on here, and same, I just keep it as a stressing 98% level, and then just add there is no water, display as a red color. After that, greater than pixel, just use the yellow color, greater than green color, and water body and display as a suppose blue color. Okay, positive value. So then just apply and also import this visualization. So now it will be added the new variable. If you check, we find out this type of variable. Just copy and paste after the object name. Just paste and give a layer name. I put the layer name suppose wet MNDWI and run the code. So now we generate this type of imagery. So first time we make the dry imagery, then rainy imagery, and then we create MNDWI in the dry season, and then we create for MNDWI for rainy season. So if you check this type of result, you find out in here. So this is the result for rainy season or wet season, okay, and this is the result for dry season. So if you check what's the difference between two map, so you can see for this type of place there is no water in the dry season, but in the rainy season you can see there are the water. Okay, blue color indicating about the water body. Also you can see for this place, for this area, there is no water in the dry season, but when I open the rainy season you find out the water. Okay, so now we try to detect the water body and also compute the area. Okay, so let's go and try to detect the water body. So for that, we can apply a threshold value and then we can easily separate the water body from this imagery. Suppose this is the imagery. So from this MNDWI imagery, I just separate only for the water pixel. So this type of water pixel I just take and remove other pixel. Other pixel I don't need. So for that we are just applying a threshold value, and this threshold value we can compute it using different way. So I'll show the all of way step by step. So first of all, suppose I want to just make the water body map from MNDWI. Okay, so just I make the water body map from MNDWI for dry season and wet season. So for that, just I take a variable. Suppose put the variable name, you can put any name. I put the name, suppose dry water. Okay, and I already make the dry MNDWI, just I call, and I just take only for greater than 0. Okay, so I just take only for the greater than 0 means that I just take only for the positive pixel, and positive pixel is indicating the water body. Okay, and then I want to display the layer, map.add layer of dry water, and I just make the binary class. So min 0 and max 1 binary class I just create, and also add the 2 color for binary map. So where there is no water, it shows as a gray color, and where is water, it shows as a blue color. Okay, and I put the layer name, it's a dry water, and run the code. So now it's create the another layer, and this layer basically store it only for those pixel greater than 0. Greater than 0, mainly all positive value it's indicating. So we find out, you can see this type of water body. You can see, we find out. So this is the water body, and this type of gray color, there is no water. Okay, so this is the water body we find out. So this is the water body map we find out in the dry season. So now, so same things we do for the rainy season and then check. So the same procedure just apply. Just copy the same line of code, just copy and paste here. So I want to create for dry season. So just call the MNDWI in the rainy season. This variable just copy and paste here. And I put this variable name, suppose wet water. Okay, or wet season water. Just copy and paste here. So now it's create the another layer. Okay, let me change the layer name. So just I put the layer name. Okay, just I put here the layer name, wet water. You can put any name as a layer. So now we check, we find out this type of water body pixel in the wet or rainy season, and this is the water body for dry season. You can see what is the difference between the two map. Okay, so first one, this map for dry season. In the dry season, it's not much water body, we find out, but in the rainy season, we find out the lot of water body. We find out the lot of water body pixel. If you check, we find out lot of water body pixel. It increase. Okay, so now we try to compute how much water body increase, in the rainy season. Okay, and how much area we find out the water body in the rainy season, how much water increase. So if you check, so this is the permanent water. So this water is available in the rainy season as well as also available for the summer season. Okay, for this type of place. But when I open the rainy season, if you check, then it increase lot of water body pixel. So now how I can decide only for rainy season water, how much water is increased in the rainy season, I want to monitor it. So let's go. How I can do that, I will show you that. So for doing these things, first of all, we need to compute the histogram. We need to calculate the histogram, and we need to create that frequency histogram for these two images. Okay, for MNW in the dry season and also for rainy season. So both of imagery, we need to compute the frequency histogram. Okay, so let's go try to compute the frequency histogram and then check the result. So let's go. So for doing these things, compute histogram for rainy and dry MNDWI. So let's go try to make the histogram, and from this histogram we can take the decision. Okay, basically threshold value decision we just take from this histogram. So for that, just apply a function UI dot chart dot image dot histogram, and I want to compute the histogram for this dry MNWI. So dry, I just put, and then put the study area, suppose ROI 10-meter resolution for Sentinel I put, and I want to print. So just I use the print function here. Just I put the one line of code at the same time. Okay, just I print, as well as I also want to print just same things I want to do for that rainy season. Okay, just call the rainy season NWI, just copy and paste here. So now run the code. So now it create the two histogram. So from that we take the decision, and then we can easily separate the rainy season water. Then we can compute it how much water body increase in the rainy season. So if you check, we find out this type of histogram. So this first one is for dry, and this is for your rainy season. Okay, so we find out, if you check it, just click on here. So this is the result. This is the result for dry season. Okay, so you can check in the dry season all of pixel. So negative pixel, it's not the water body. Okay, you can see negative, it's not the water body. So if you check, we can get you can see 0. Okay, so water body start from here. Okay, so greater than 0 all of pixel. So this type of pixel, it's indicating about the water body. It's indicating about the water body. You can see this type of pixel. This type of pixel, it's indicating about the water body. This is the 0. You can see from here 0.70, 0.39. So it will be start from after 0. You can see this is the 0. So greater than all of pixel. So this type of pixel, mainly greater than 0, all of pixel, it's considered about the water body. So now just we find out from here the highest water body pixel. If you check it, we find out the highest water body pixel 0.3 or 0.35 or 0.3, we considered 0.3. You can see 0.3. It's the highest water body pixel in the rainy season. We consider it 0.3. Okay, 0.3 is the highest MNWI value in the rainy season. We find out from here. So 0.3 we consider. So 0.3. Okay, I'll write the comment in here. So in the dry MNWI, we find out 0.3. It's a highest pixel value of MNWI. So after that, if you check in the, so for the rainy season, what happened for that, you can see in the rainy season, if you check, it will be start from 0. This one 0.0. So 0. So it will be start from here. So from after greater than all of 0, from 0 it can including about that water pixel. So now from here we are just find out the highest pixel value. You can see find out the 0.8. Okay, you can see 0.8. So 0.8 is the highest pixel value of MNDWI. Okay, 0.8 we find out. So just I consider in the 0.8. So this is the 0.8 and it's a dry, it's a wet or rainy season. I put the wet MNDWI value. We find out that 0.8. Okay, so in the summer season we find out the 0.3, and in the rainy season we find out the 0.8. Okay, so if you check it from here, 0.3 you can see we find out in here 0.2, 0.2, 0.3. So it will be, this is the 0.3. So this is the range of dry season MNDWI value. This is the range. So now from 0.3, all of pixel greater than 0.3, all of pixel indicating about that rainy season water body. Okay, so you can see 0.3 is the highest. We already checked from this graph. You can see from this graph we find out the 0.3. It is the highest MNDWI value. So from greater than all of pixel from 0.3, greater than all of pixel from 0.3, it indicating about the rainy season water body. Okay, so I hope you can got the idea how it will work. So anyone any question or any confusion, you can ask me please about this histogram. Yes, please.
Excuse me, sir.
Please.
Can you hear me?
Yeah, I can hear you. Please.
Actually, I am confused and I am not clear. Can you repeat again the histogram?
Okay. So for the histogram, we create the histogram. Basically, you can see this histogram. It's a frequency number and it's a pixel number. Okay, it's a pixel number.
Okay.
So basically, for positive pixel, it's indicating about that water body. Okay, so if you check the positive pixel for MNWI positive pixel, so you can see it's a negative pixel, so that it's not the water body. So water body will be start after 0. You can see this is our boundary. So this one negative. So you can see this is the 0.08, 0.08. So 0.0. So after greater than 0, all of pixel, it's indicating about the water body pixel. So we just compare. So this histogram and this histogram we are just compared. So if you check this histogram basically for dry season, in the dry season what's the highest pixel? Okay, we find out the in the dry season highest pixel of NDWI is the 0.3. Okay, 0.3 is the highest pixel value of NDWI in the dry season. But for the rainy season, if you check in the rainy season, we find out that what is the highest pixel. In the rainy season, we find the 0.8. So it's the highest pixel of NDWI in the rainy season. So now greater than, if you check greater than 0.3, so 0.3 start from here, you can see 0.3. So greater than all of pixel, so this type of pixel, it's indicating about that water body. So now we are just identify only this type of pixel. Okay, greater than 0.3, only this type of pixel we consider and display on our map. Then we find out only for those water which are available in the rainy season. Okay.
Okay. Excuse me here. Sir, can we use this histogram in our paper or?
Yeah, we can also use it. Yeah. So we can also
Do
use.
you have any example, any article?
Yeah, we can
You
also
can
use.
share with us and it's,
Yeah, I also share you this type of. There are a lot of paper is already available for the flood mapping or water logging area. So how we can detect. Okay. So there are a lot of
Okay,
paper is available. You can simply search on the ResearchGate or Google Scholar. We find out lot of paper this type of topic or flood mapping. Okay, so I'll share with this type of reference also. Then you can also get the more
Okay, thank
better
you, sir.
for theoretical knowledge. Okay. Okay, so let's go. We find out this type of things.
Excuse me, sir.
Yeah,
Again.
please.
Yeah. Is there any other method for detecting this difference apart from using histogram?
Yeah, it also another. Suppose we are just create the map, but from the histogram we take the decision. Okay, so how I can separate, how I can detect the rainy season water. Suppose I have suppose in the flood map, we find out that permanent water and flood water. So how I can detect the flood water? Okay, for detecting the flood water, we are just create this type of histogram and create a equation. We are just create a equation. Okay, so then we can easily detect the flood water. So this is the flood water, this is the non-flood water, or this is the permanent water body. Okay, so we take the decision from the histogram. Suppose in this case, for my study area, I find out that 0.3 and also find out the 0.8. Okay, so 0.3 is the highest, it's a highest pixel value for dry, and this is the highest pixel value of wet season. So now we are just apply this value and then we make a decision. Suppose what is my decision, you can check. So I put the decision MNDWI wait, this value greater than 0.3 and MNDWI dry less than 0.3. Okay, so if I just apply this condition, suppose MNDWI in the wet season greater than 0.3 and dry season less than 0.3, then I find out only for those water which are available in the rainy season. Okay, so now I find out the 0.3, this is my threshold value to separate these things. So now just we try to apply it and then check the result first, then I also explain again. Just a minute. So just take a variable. Suppose I put the variable name is that rainy water, or you can put any name, no problem, and then call the MNDWI rainy. Just paste here and apply here the greater than 0.3 and also apply the dry. So MNDWI dry, these things less than 0.3. So now I want to add it. Just map.add layer of this rainy water. Okay, and I want to display, suppose as a binary class 1, and I add the plated. Suppose if there is no water, it shows as a gray color, and if the condition, if the pixel condition this equation, it shows as a suppose red color. Okay, then give a layer name. Suppose I put the layer name, it's a rainy water, and run the code. So now if you check it, okay, so if you check it, we find out this type of pixel as a red color, and if you check the value, okay, just check the value. Suppose just click on here. Okay, you can see, find out that in the weight MNWI value is the 0.8. Okay, and 0.8 is greater than from 0.3. Okay, 0.8 is greater than from 0.3, and you can see, find out that in the dry we find out the negative 0.2. So 0.2 is less than 0.3 from this dry. So let's check another one. Suppose I want to check for another red color pixel. Just click on here. So you can see, find out the 0.8. Okay, 0.8 is greater than 0.3 from MNW in the rainy season, and we find out the dry season. You can see negative 0.1. So it means that it less than 0.3. Okay, negative 0.1 is less than from 0.3 from MNW in the dry season. So we find out this type of place, and it look more better if I just apply the single class. Suppose not create the binary class. Suppose let me try to add only for the single class. Just apply the self marks function to create the single class. Okay, just display only for the single class. So for that, just remove this one, and I put only for the one color, because now we create for the single class. Just remove the binary class. Okay, as well as I also create for this one. So just put the self marks to create the single class, and remove the 0 and 1. It's not need. It's need only for the binary class, and I will display it only for that. Okay, one color for blue, and also same process. These things, just I remove the binary class and apply here dot self marks, and I put here. Okay, if you want, you also add the different color. Suppose I put here, it's a pink color. It's in the water. So now run the code.